I hope everyone is enjoying their summer. Wanted to talk about this instrument, which is known as an oscilloscope. The scope, of course, means to see, and when you use the word oscillate, it means something that's changing. And anything that we can watch with an electrical signal, we can watch on an oscilloscope, especially if it's changing at all. And basically, an oscilloscope is a cathode ray tube like this. So there is a place here where you connect to high voltage to generate electrons, and then the electrons can be deflected by these plates. You can see there are connections here for these plates. The electrons aren't visible to us, but they stream and strike a fluorescent face on the tube, and that allows us to see where the electrons are actually striking the front of the tube. And that's basically what's inside of here. And you can see there are electrons coming from the back end of the oscilloscope towards the front end of this tube. And because the electrons cause the coating to fluoresce, we can see a green light. Now remember, electrons are electrically charged, they're negative, and since they're moving, they should feel any magnetic force. So I have here a couple of magnets, north and a south pole. So if I put the magnets like that, I should be able to deflect the electrons in that direction. And then of course, if I would turn the magnetic field the other way, the electrons get deflected in the opposite direction. So you can control where the electrons are using magnetic fields like that. It's possible, it looks like right now, you have a solid line here of electrons. That's not quite the case. I can show you what I mean here if I can adjust it just a little bit. What's actually going on is that there is a single beam of electrons that are being guided from left to right across the screen. And if I want, I can increase the pace at which those electrons move from left to right. And it goes so fast that pretty soon to us, it looks like we're looking at a solid line. It's not quite the case, but it looks that way because of the rate at which the electrons trace across there. Now, one of the things that we can easily monitor is any electrical signal. So I have right here a very small sine wave generator, and it does exactly what it sounds like. It will generate a wave that looks to us like a sine wave. So if I connect my oscilloscope, I have that end connected already, and I connect this end, and I'll have to adjust the rate at which, here we go, a little slower. Now you can see there's a nice sine wave, and I even have the ability to change what we call the frequency, how fast that sine wave is going up and down. And that probably doesn't mean so much to us, but we can make it more interesting if we connect it to a little speaker. So I have a small audio speaker here, and I'm going to turn it on first, turn on my speaker, and then I'll simply connect the speaker to the sine wave generator. And now you can hear, and I'll have to make this a little bit more sensitive. Or no, excuse me, I just lost my connection to the other end here. There we go. So now, not only can you, see if I can make that on screen a little better. There we go. Now not only can you hear the sine wave, you can see it. And if I change the frequency, shorter wavelengths means a faster frequency, and we can hear it as a higher pitch. And if I lower it, the waves get further apart because it's not going up and down quite so quickly, and consequently we get a lower pitch. And that's kind of annoying, so I'll turn it off. But anyway, I wanted to introduce you to the oscilloscope and how we use it to measure electrical signals, and show you that we can actually generate a wave that we can both hear and see at the same time. So again, thanks for watching, and we'll have something again for next week.